Hello everyone, I'm Shuchang Xu from the Hong Kong University of Science and Technology. Today I'm excited to present our work, Memory Revival, supporting photo collection reminiscence for people with visual impairment via a proactive chatbot. This work is done in collaboration with Chen Chang, Liu Zichen, Jin Xiaofu, Professor Yuan Linping, Professor Yan Yukang at the University of Rochester, and Professor Qu Huamin at the Hong Kong University of Science and Technology. People with visual impairment save photo collections for memorable events. Oh, sorry for the screen. Okay, now we are okay. So people with visual impairment save photo collections for memorable events. For example, they save photo collections for a trip abroad, a graduation ceremony, or birthday party. However, it's highly challenging to reminisce with a photo collection without vision. While AI image descriptions provide essential image understanding support, they fall short in supporting reminiscence because they lack sufficient details and they result in a tedious experience for many photos in a collection. Consequently, people with visual impairment often reminisce by chatting with sighted friends. This chat-based reminiscence is already familiar to people with visual impairment. However, the reliance on sighted help restricts the flexibility of their reminiscence activity. In response, we explored designing a chatbot to support independent photo collection reminiscence for people with visual impairment via natural language communication. To inform the chatbot design, we conducted a formative study with 8 people with visual impairment who regularly reminisce with photos. Participants first received a semi-structured interview and then participated in a tech probe session where they used a chatbot to reminisce with a photo collection. Each participant shared a photo collection for an event, and they reminisced with the photo collection by conversing with a naive chatbot based on GPT-4V, the state-of-the-art large multiple model. Each time users gives an input, the chatbot uses 2 steps to generate a reply. And by analyzing users' input, our study reviewed 4 types of information needs commonly required by people with visual impairment during reminiscence. The first need is a storyline that summarizes the whole story in the photo collection. And the second need is a scene activity regarding who, what, when, where information in the photos. The third type of information is scene details regarding people, food, animal, plant, text, etc. And the fourth type of information is new scenes. Participants commonly ask these questions when they have explored the current scene. However, participants face 2 primary challenges when conversing with the chatbot. The first challenge is the disorganized conversation flow, because the one question, one answer communication style led to the information being scattered across multiple rounds. This made it difficult for participants to form a clear story of their past. And the second challenge is a lack of proactive guidance, because people with visual impairment couldn't visually explore new scenes, and the lack of proactive guidance from the chatbot further challenged participants in deeply engaged in the conversation. To address these 2 challenges, we present Memory Revival, a proactive chatbot that actively guides people with visual impairment to reminisce with a photo collection. Given a photo collection, Memory Revival would begin the conversation with a clear storyline, help users recall past activities, enrich their memories by gradually presenting details, and actively suggest new scenes at proper conversation rounds. These 4 types of information elements form a natural conversation flow, and will demonstrate it using conversations in the user study. First, memory reviver begins a conversation with a clear storyline. The storyline consists of all the scenes, with each scene consisting of a short sentence. For example, memory reviver would introduce the first scene as sculptures on Nami Land. And after introducing the storyline, memory reviver would help users enter a scene, and memory reviver would actively introduce the scene activities using who, what, when, where aspects with supporting reasons. And the conversational example shows that memory reviver would introduce the first scene in details using who, what, when, where, and also provide the reasons for the location. Following this, memory reviver would proactively suggest new details to enrich user memories. In each round of conversation, memory reviver not only responds to users' input, but also actively suggests new details to enrich user memories. And when the current scene has been thoroughly explored, memory reviver would actively suggest new scenes. This is achieved by providing a summary of the current scene and suggest the next scene. Overall, this design keeps users engaged in the conversation, and the conversation ended when all the scenes have been explored, therefore enabling users to fully relive past memories. Memory reviver is powered by two novel features. The first feature is a memory tree, which organizes information in a photo collection into a hierarchical structure. And the second feature is a proactive strategy, which delivers information in the memory tree at proper conversation rounds. So in the first feature, memory tree organizes information using a tree structure. The top level is a storyline, the mid level is a scene activity in each scene, and the bottom level is the scene details in each scene. And we built an automated pipeline based on GPT-4V to extract those information. Results show that our pipeline achieved over 90% accuracy for photo collections used in the user study. And the second feature is a proactive strategy, which delivers information in the memory tree at proper conversation rounds. This is achieved by using a state machine to control when and how to present the information to users. To evaluate memory reviver, we conducted an evaluation study with 12 participants who regularly reminisce with photos. Each participant used a memory reviver and a GPT-4V chatbot, the baseline chatbot used in the formative study, and they used both chatbots to reminisce with two similar photo collections. And before and after users converse with each chatbot, they compose a memory narrative, and we use the word count of the memory narrative to compute a memory ratio, which evaluates the effectiveness of memory reviver and the chatbot in facilitating memory recall. Results show that compared to the baseline GPT-4V chatbot, memory reviver significantly facilitated memory recall, and memory reviver achieved 3 times as much memory recall than the baseline. Participants also noticed that memory reviver delivered an engaging reminiscence experience, making them feel like they are watching a movie of their past and playing a side-scrolling game. Participants also said that memory reviver elicited strong positive emotions, made their eyes welled up with tears of joy. Memory reviver also facilitated self-reflection for several participants because such independent reminiscence allows them to reflect on their own past more deeply. And for future discussions, based on our findings, we discuss directions to personalize memory reviver based on different user contexts, such as using users' chat histories to personalize future responses. Future work of memory reviver should also consider using local vision language models to ensure data privacy. Moreover, in more high-stakes scenarios, such as providing real-time guidance, the proactive guidance of overview-first detail-on-demand design could be similarly adopted. So that's all for Memory Reviver. Thank you for your listening, and I'm happy to take any questions.
All right. Line up if you are interested in a question, or if we have anyone who can't access the microphone, please raise your hand and we'll bring it to you.
Hi, Shu Chang, nice work. I'm Jing Yu from Quebec AI Institute. So I want to ask questions about the ownership of long-term use and memory. So as the memory retriever collects more interaction and memories, what are your thoughts on the ethical considerations surrounding like data privacy, especially given that this involves like deeply personal memories? Like, how do you envision addressing issues like ownership and control of those personal data over long-term usage?
Yeah, thank you, Jingyu. This is a really good question. And we carefully think about the ethical considerations behind the reminiscence activity, because personal photos actually represent very personal information for our lives. So we discussed when deploying Memory Reviver for actual use, we will need to deploy local vision language models, such as many mobile vision language models, to ensure data privacy. Moreover, we think it's critical to clearly inform users of how their data will be used when they use Memory Reviver. So those ethical considerations are essential in future deployment.
Okay, thank you.
Thank you.
All right, and let's thank our speaker while we transition laptops.
Yeah.